Several hundred years ago, our solar system underwent a global catastrophe, passing dangerously close to a black hole or a similar object in strength. Under the influence of powerful gravity, the flatness of the ecliptics of all planets shifted, simultaneously shifting the axis of rotation of the planet. This hypothesis finds its confirmation practically everywhere you look. All satellites and planets of the solar system are covered with craters, like shrapnel, scars, literally after the war. Absolutely everyone got it. So much so that many researchers consider this to be some kind of orbital bombardment, nuclear war, or just Star Wars of some ancient cosmic civilizations. Official science simply modestly stretches the appearance of craters over billions of years. This is exactly what we are going to discuss now. Good day. You are on the Epoch of Distrust channel with Mikhail Kolnikov. Those who have come across my channel for the first time are probably slightly shocked by these conclusions. Therefore, before proceeding to this video, at least watch the previous two, otherwise you won't understand how I reached these conclusions, and certainly get rid of a multitude of questions. Well, we continue to consider the consequences of the supposed passage of the solar system past a black hole. In the last episode, I clearly showed what will happen to the objects in the Kuiper belt, which significantly slowed down their speed under the influence of foreign gravity, but at the same time were far enough from the center of attraction and therefore were able to stay in our solar system after its departure. And the asteroids, of course, remained, but completely or partially lost their speed, which means they had to change their orbit. Firstly, it became strongly elongated, and secondly, its perihelion came very close to the Sun. In some cases, when the speed of the asteroid dropped almost to zero, the perihelion of the orbit shifted right inside the Sun. That is, the asteroid simply fell on it in the end with a speed of about 650 kilometers per second. The cosmic evidence in favor of this phenomenon is the gap in the Kuiper belt, visible on models made by the Small Planet Center. At this point, it's worth pausing for a moment, as the astronomers probably have some plausible explanation for this, and they really do. It is believed that this blind spot formed not by the absence of any objects in this part of the belt, but by a simple glare. The inconveniences caused by our own galaxy, the Milky Way. Its disk causes a strong glare and interferes with the detection of objects in this zone. Sounds quite reasonable and acceptable. That's exactly why we're going to make a stop. We've heard the astronomer's argument. Now let's think. The gap takes up about 1/5 of the Kepler belt's disk, so about 36 degrees. Compare it with the panoramic shots of the Milky Way, and yes, indeed, the gap takes up about 36 degrees. For an even count, let it be. Everything is correct so far. Now let's ask ourselves a question. How do they discover planets and stars in the first place? Correct, with telescopes. The most diverse ones, from ordinary mirror telescopes to huge and even radio telescopes. And if the light from the Milky Way can interfere with a regular mirror telescope, it doesn't affect a radio telescope. Radio telescopes, for example, allowed us to scan the surface of Venus, regardless of the intense sunlight or the thick layer of clouds under the pressure of 90 atmospheres. Radio telescopes allow us to look directly into the center of our galaxy. Even the central star concentration doesn't interfere with them. So why did some poor handle of Orion cause such difficulties in detection? Moreover, our astronomers have reached such heights in photography that they can use the reflected light of stars to shoot the backside of Pluto, for example, which is in the same belt of Kuiper. Small space objects are found using the comparison of negative shots taken at a certain time interval. By comparing such photographs, astronomers detect movement and, accordingly, a planetoid. However, for some reason, no method is suitable for scanning the gap in the Kuiper belt. Another argument is the fairly well-studied asteroid belt between Mars and Jupiter. It lies in the same plane as the Kuiper belt. However, it is quite well studied at the moment. More than 500,000 asteroids, and there is no glow from the Milky Way on it. Maybe it's not there because it rotates quite quickly and completes a full rotation in just 50 to 60 years. And again, it sounds reasonable. In that case, a few calculations. Although the search for Kuiper was predicted and discovered quite a long time ago, its active study began around the year 2005. Approximately from this moment, data about him began to come in avalanche-like. Therefore, let's take this year as the starting point. So, the Kuiper belt begins approximately at 30 and ends approximately at 55 astronomical units from the Sun. Its ring diameter equals 90 to 100 astronomical units, and the full circumference along the outer edge ranges from 280 to 315 astronomical units. The farthest object orbits the Sun at a speed of approximately 114 astronomical units per year, while the closest one at a speed of 163 astronomical units per year. That is, over the past 16 years of research, the farthest object in the Kuiper belt should have moved and thus shortened the gap by 18 degrees, that is, twice as much, and the closest
correspondingly
by 26 degrees or 2/3. And so the collapse should look something like this. However, the collapse remains as it should have been at the very beginning of the investigation. Well, and one more argument. On January 19th, 2006, the interplanetary automatic station New Horizons was launched. The official reason for the launch is to explore Pluto, its moon Charon, and also a certain binary object located in the Kuiper belt 2014 MU69, conditionally called Ultima Thule. In other words, this station was sent specifically to study the Kuiper belt. It is from it that we received a huge amount of data on trans-Neptunian objects and high-quality photos of Pluto. However, the most intriguing aspect lies in its flight trajectory. By sheer coincidence, it is flying right into this very gap. At this moment, the device has already passed through the entire Kuiper belt, moving away from our planet more than 50 astronomical units. Now the belt is behind the device. No Milky Way light is hindering him anymore. However, the pit, as it was, still remains in place. So what the real purpose of this device is, you judge for yourself. One can bring up many more arguments against lighting the Milky Way, but I think this is enough for now. Well, we return to our main topic. Thus, a wave formed in the Kuiper belt, a kind of tsunami of millions of large and small asteroids and planet fragments. And this entire armada very slowly began its journey along a new trajectory towards the Sun. As we already clarified in the last series, if the solar system was inhabited by civilizations, they would have had about 60 to 70 years in reserve before the first strike. So, if I were in their place, from this moment, I would have disregarded all norms of decency and morality, all monetary and commodity relations, and would have directed all the power of civilization to the attempt to survive. So the first thing the wave encountered was Neptune's orbit. Depending on the distance of Neptune itself from the flight zone of the meteorite cloud, it could equally likely fall under its destructive influence, or it might not. Let's take a wild guess. The tilt of Neptune's axis is about 28 degrees, which means that it received roughly the same influence as Mars at 25 degrees and Earth at 23.5 degrees. So he was quite far away, so the first wave probably didn't affect him. The next was Uranus's orbit. The story here is the opposite. Uranus is practically lying on its side, turned almost 97 degrees. This means he was as close as possible to the gravitational object. However, that's exactly why he also missed the main encounter with the stream. He simply managed to get out of its way in time while the asteroids were gaining speed. At this moment, one more step back needs to be made, once again explaining that the change in the tilt of the planet's axis occurred precisely under the influence of an external force. Since all the planets were initially formed in a single plane for the solar system, not only were their axes of rotation perpendicular to this plane, but also the satellites that formed simultaneously with them were on the same plane. And even now, this property has been preserved. No matter what planet we
would take,
all its nearest and largest satellites lie strictly perpendicular to the axis of rotation of the mother planet. For example, Jupiter. The plane of rotation of its main Galilean satellites has exactly the same inclination to the plane of the orbit as Jupiter itself, that is, 3 degrees. Saturn still is about 27 degrees, and its main satellites and rings have exactly the same tilt. Uranus is also not an exception. It is tilted at 97 degrees, and the flatness of its satellites' orbits has exactly the same tilt. Astronomers, of course, have put forward their hypothesis here, according to which the satellites of Uranus entered into resonance with Uranus itself, and, having scattered it, thus knocked it over. Let's test this official hypothesis for robustness. First, right next to Uranus is Neptune, which also has satellites. And in terms of size, it is quite comparable to Uranus. However, the satellites did not bypass Neptune for some reason. You might tell me that Neptune only has 2 satellites, and they are both quite small, with a diameter of about 35 kilometers each. And I would agree. However, in that case, let's look at the sizes of Uranus's own satellites. They are also quite small. The diameter of the largest of them is about 3,000 kilometers. That is less than our moon. And the rest are even smaller. But despite this, the diameter of Uranus itself is 4 times larger than Earth's. Accordingly, its mass, gravity, and the number of moons it can hold are much larger. And this means that in proportional terms, the total weight of all Uranus's satellites is less than the weight of the moon relative to the Earth. And this, in turn, means that either astronomers simply glossed over an obvious problem to avoid unnecessary questions, or Earth is soon expecting a similar upheaval. After all, physical laws can't work in one case and not in another. And why then hasn't the Earth flipped over yet, simultaneously destroying all life? Perhaps many will tell me right here that the Earth has flipped over many times already. But the point is that we're not talking about a flip of 180 degrees, but about a position on its side, which is a completely different matter. With a flip of 180 degrees, everything will remain the same, except that the sun will rise from the other side. But with a tilt on its side, life will be completely destroyed, simply because one hemisphere will be scorched by the sun and the opposite one will freeze. That is, the official hypothesis about the reasons for the tilt of Uranus's axis is at least illogical and inconsistent. Meanwhile, our asteroid stream has already gained a decent speed and is approaching Jupiter. This is where the most interesting part begins. The tilt of Jupiter's axis is only 3 degrees. He says that he was probably at his farthest distance during the passage of the hole, on the opposite end of the solar system, for example. However, by the time the asteroid stream reached Jupiter's orbit, almost 60 years had passed. The stream gained a speed of about 16 to 17 kilometers per second, and by that time, Jupiter had already completed 5 full orbits around the Sun. Its year is only 11 86/100ths of an Earth year, and the length of the asteroid stream could be 10 to 20 years, depending on the initial speeds of the asteroids. Thus, Jupiter hit a jackpot. Being the most massive body at that moment and in that area, it passed through the stream several times. Some of the asteroids fell directly onto it, increasing its already considerable mass. But most of it simply scattered to the sides, giving the meteorites an additional lateral impulse. Why is this important? Firstly, because a large part of the asteroids, which initially had no lateral impulse, should have simply fallen into the Sun. And the other part, which had this impulse, should have simply dropped to lower orbits, where it should have been captured by the giant planets. However, we know that Neptune was quite far away, and since a year for it lasts 164 Earth years, it simply could not get there in time for the collapse. Uranus, on the other hand, was as close as possible to the scene of action. However, years passed while the asteroid stream was gaining the necessary speed. By that time, it would have inevitably moved to the opposite side of its orbit. A year on Uranus lasts 84 Earth years. And so, it could no longer protect the inner planets of the solar system. Only Saturn and Jupiter remained. They were the ones left. As the strongest gravitational objects in this part of the path, they literally began to devour the passing objects. Now let's take a closer look at the chart that I briefly mentioned in the video about Mars. The mass of Jupiter greatly differs from what should have been during the formation of the solar system from a single protoplanetary disk. In the video about Mars, I said that its mass should be no more than 80 times the Earth's, assuming it swallowed up all the matter between Mars and Saturn. However, in reality, between Mars and Jupiter, there could have comfortably been, no, not the unfortunate Phaethon, but at least 7 more planets. And this, considering the progression towards a gradual increase in the mass of the planets and the distance between them. If we take a distance analogous to the distance between Mercury and Venus, Venus and Earth, Earth and Mars, that is approximately 50 million kilometers, then there should have been as many as 12 planets in the area between Earth and Jupiter. Not some unfortunate Mars, slightly larger than the Moon, but 12 full-fledged planets. And the mass of Jupiter itself, by the way, should have exceeded the Earth's by 5 to 6 times. At the same time, he could freely maintain the existing Galilean satellites. Now a large part of the commentators are starting to write angry lines about the rules of Titius Bode in Impatience. Let's wait a couple of seconds. Let's give them a chance to let off steam. And after that, let's remember that the Titius Bode law is not a law. It's just a postulate, in no way justified from the point of view of physics. It's a rule that just exists, and there's simply no explanation for it. It's just a mathematical formula that fits the actual reality, and it works. Well, how does it work? Judge for yourselves. The actual position of Mercury differs from the calculated one by 2.5%. The position of Venus is off by 3%. Mars' position is off by 4%. The asteroid belt is wandering in a wide range. The position of Saturn differs by as much as 5%, Uranus by 2%, and Neptune completely breaks the rule. Is this precise mathematics? With such adjustments of 5%, where every 5% is a distance of 1.5 million kilometers? Only Earth and Jupiter definitely correspond to their position in the rule. But Earth, because it is the point of reference, it simply cannot miss. And Jupiter is the most massive body, and therefore it is also taken into account in the equation as the second reference point of calculation. So the Titius Bode law is pure ear-pulling. And until the reasons for the appearance of this rule are explained, it is not a law. Then why do we need these charts? So, they are needed to understand what, where, and when was located. For example, from the chart it becomes clear that despite the skewed axis, Uranus almost did not change its position in the solar system. Neptune, on the other hand, has moved significantly towards the edge from its initial orbit. Jupiter and Saturn remained in their places, but Saturn gained about twice as much weight. Jupiter not only absorbed part of the passing stream, but possibly intermediate planets, if there were any, of course. Its mass increased almost eightfold. It expanded and began to devour its own satellites. For example, Io. It was detailed in the previous series. Perhaps there were other satellites before Io, about which we will never know. Saturn's rings appeared roughly the same way. Their round shape testifies to this. The thing is, a planet can tear an asteroid or another planet apart if it enters what's called the Roche limit. However, its orbit, and consequently the ring of debris, will be elliptical. However, Saturn's rings are round. This suggests that the shattered satellite originally formed with Saturn and then ended up in Roche's pole.
After an unexpected event.
The expansion of Saturn and consequently the enlargement of the rupture zone. The same thing, for example, will happen to the Moon if it suddenly finds itself 16,000 kilometers from the Earth, or if the Earth suddenly increases fivefold. So, when the stream of asteroids passed by Jupiter's orbit, it had already gained a speed of 16 to 17 kilometers per second, and the count went on for weeks. Approaching the Sun, the stream of asteroids became denser and denser, according to the law of inverse squares. At some point, a unique relationship of the density of the stream and the orbit of one of the planets, Earth and Venus, occurred. The stream was already maximally dense, which on one hand guaranteed the complete destruction of everything it encounters on its way, and on the other hand, for the same reason, the chances that it would pass the planets earlier or later also increased. This window of opportunities was small, and Mercury did not fall into it, too close to the end point of the stream, too small orbit radius, reaching the Sun. The stream at a gigantic speed, 600 kilometers per second, began to make a turn. And this was another key moment. At the point of perihelion, the stream began to break up large asteroids into smaller ones and dust. Dispersion in directions with a sharp change in the flatness of the asteroid orbits, and the consumption of most of them by the Sun. After this maneuver, the flow went in the opposite direction. However, while doing this, it reduced the speed, changing the direction of some of its objects, and partially disintegrated into smaller fragments. And again, encountering Jupiter and Saturn slightly less on its way, it partially consumed them, partially leveled out. By the way, about leveling the orbits. Remember our experiment with 3 moons or several bodies in Earth's orbit. Recall we placed several massive bodies with initially elongated orbits around Earth. During the modeling, some of them collided, some were thrown out, and the third part leveled its trajectory around the Earth, and it became almost round. And that's how the Moon appeared. But the same thing can happen on a much larger scale. Accommodating a whole stream of asteroids moving along an elongated parabolic orbit between the Sun and Jupiter, some of them gradually level out the trajectory and occupy a more or less circular orbit roughly in the middle. This is exactly how the asteroid belt appeared. Not as a result of the explosion of the planet Phaeton, but as a result of leveling the orbits of fragments of the meteor stream from the Kuiper belt. Knowing that at best only a tenth of the total mass will occupy such an orbit, and knowing that there are currently more than 500,000 known objects in this belt, we can assume how huge the initial stream was. Well, in this series we have already fantasized with you more than enough. All that remains is to explain why in the last series I did not show the orbits of most of Jupiter's and Saturn's satellites, stopping only at the most massive and closest ones. Well, it's time to explain. The thing is, absolutely all the other satellites are not really satellites at all. More precisely, they did not appear together with the gas giants, but were captured later from this stream. They all have two distinctive features. Firstly, they all, as if cut in half, have approximately the same diameter, about 1 to 2 kilometers, which speaks of similar formation conditions. Most likely, these are fragments of shattered planets or larger asteroids, and the quite precise size of 1 to 2 kilometers, as if cut with a knife, speaks of an equal gradient of forces. That is, they are all pieces of one or several identical objects. Secondly, their orbits have a very steep inclination to the plane of the gas giant's ecliptic, which again speaks of capture from the side. Well, and the quantity speaks for itself. To capture 70-80 such
Satellites, gas
giants had to pass through a very dense stream of asteroids. Friends, none of us are afraid of mistakes. And if you see a flaw in my logic, don't hesitate to leave a clear, concise, and unambiguous comment under the video. Subtitles created.